Hello, everyone. Good morning. Can you hear me?
We can hear
Yeah,
you.
Okay, great. Okay, yeah, just want to make sure you can hear me. Okay. Hope you have a nice long weekend. Okay, and I think today we will go to the next chapter, right? And I think I have already uploaded the first assignment. And if you have any question, you can contact our TA or contact me directly. But I do think the assignment one is not difficult. It's some simple calculation and the concept, okay? So I think today we will start with the second chapter. Sorry, I didn't have a time to upload the slides yet, but I will do that after the class. Okay, sorry about that, but I will do that immediately after class. So today I think we will start with chapter 2, the application layer, right? Still remember, we have the different layers of the um, internet, right? From the application layer to the transport layer, right? Down to the physical layer. So we will from top to down, right? One by one. So as a beginning of the detailed description of different layers or application layers, our first focus. So okay, so the slides looks good, right? So you can see the slides. Okay, I just want to make sure. Okay, so so for this chapter, we will discuss something about the principle of the network application layer, right? And the different protocols in the application layer, for example, HTTP, SMTP, IMAP, and corresponding their application web and the emails, right? And we also will talk about the domain name system, DNS. So you don't need to input IP address, right? Instead, you can use DNS to find your web service, right? And we will also talk about the P2P applications, video streaming and the content distribution networks, and the socket programming with UDP and TCP. Okay, so that's the content we will cover in this section, and I believe this section many concepts you may be familiar with because you are using the web apps every day, web serving, right, and the email every day. So for some protocol connect to the transport layer, you may be familiar here. Okay, um, so let's start. So the goal of this chapter is that we need to learn the conceptual and the implementation aspects of the different application layer protocols, right? For example, we need to learn the transport layer service models. We need to know the client server paradigm and the peer-to-peer paradigm, okay? So there are different models between different network nodes, right? So we need to understand here. And we also want to learn about the protocols by examining the popular application layer protocols. As I mentioned, we have HTTP for the web server and the web browser. And we have SMTP, IMAP for the emails, and we have the DNS, okay? And eventually we will learn something about the programming network applications, such as we want to know how to use a socket API. Okay, so that's the content we will cover here. So first, let's see some network applications or apps, right? So I believe most of you may be using that every day. We have the social networking, right? Facebook, Twitter, and we have the web. You are using the web browser, communicate with the web server, right, to get the web page, website, right? And you have the text messaging, you have emails, right? And multi-user network games, right? Streaming games, PC games, right? And you have the streaming stored video like YouTube, Hulu, Netflix. You are watching almost every day, and you have the P2P file sharing, right? You want to send and receive the data peers to peers. We will talk about that later, but you can do the point to point or peers to peers file sharing, right? And you can do a voice over IP like Skype. You can talk to other people in the network. You don't need to call through the phone, right? Or telecommunication. And you can do the real-time video conference like what we are doing now, right? We have Zoom for the real-time or synchronize the video conference, okay? And you can do internet search, remote logging. So for my research case, most of my students do not need to run their applications or programs locally because they have to log into the server, remote logging to the server, right? And launch or run their applications in the server side because the local desktop or laptop is not powerful, right? So we have to use the remote logging, right? So there are a lot of network applications, right? I think I'm mostly doing those things every day, right? I'm doing the Twitter, web service, email, uh, video, sharing the file, teleconference, right? I almost doing most of them every day, okay? So a lot of network applications here. So you can know what are your favorites, right? Yeah, and to create network applications, usually we write programs that run on a different end systems, right? You can write the network applications in your mobile phones, right? In your laptops, and writing the um, server, right? Enterprise servers, right? And each end system or application will communicate with each other over the network. Okay, so for example, I think this is a most frequent thing you are doing every day. You just browse the internet, right? You are using the web server software, communicate with the browser software. So generally speaking, you have the Chrome, right? You have the IE Explorer, right? So that's a browser software, and that browser software communicate with the web server software installed in the um, server, right? For example, we install, if we have the server establishing the EECS school, right? We have the server room, and that server room, we can install some server software. When you are trying to see the web page from the school, right? The news or some forms, you just input your URL address, right? And your browser will communicate with the web server installed in the ECS uh, server, right? And they can communicate with each other. They can send them the request and the response, right? So that's a simple example of the net application or program. Okay, so there is no need to write software for network core device. Okay, so network core device do not run user application, right? You just run or write your program in the end system. You don't need to care about the network core device, right? And the application on the end system will allow rapid application development and propagation, right? You only care about how you write the application level programs. You don't need to care about the network core device, right? That's will be much easier than you programming on lower level, right? So you can see here, this is the end system we are trying to target or program our network applications at, right? So here's the mobile networks, enterprise network, and different end system here. So you can see the different end system will have the different application. The different application will communicate with each other, right? Just as we explained before, applications send the packet to the transport layer, network layer, data link layer, physical layer, so on and so forth, right? But we only need to program our applications at the application layer, okay? And we will talk about that, how application will communicate with each other, for example, through the socket, right, and to the transport layer. So here is the first paradigm is client and server. So I think this is a very classic and the famous paradigm in the application layer protocol, right? We have some server, we have some clients, right? Server and the clients, how they communicate with each other. So for server, it always run on the host, okay? It has a permanent IP address, because if its IP address changes and no one can find it uh, later, right? It will have the permanent IP address and the static IP address for stability. And it is often in the data centers for scalability or for scaling, right? Because sometimes there are a lot of requests or access to the server, or request to the servers, right? In the data center, if you establish the server side, you can guarantee the scalability, okay? Or guarantee a lot of response can be processed at the same time. For the clients, it is a contact to communicate with the server, right? It may be connected time by time, right? They not always connect to the internet, right? And it maybe have the dynamic IP address, okay? Because it's not the server side, right? No one tries to access you or send a request to you, right? You are the client, you send a request to the server, right? So you can be connected time to time, and you can have the dynamic IP address, okay? It do not communicate directly with each other. So you can see here, we have the two end service, right? So if there is server established in the data center, if we have the mobile, if we have the laptop and the mobile will not communicate with each other, but they will both connect or contact with the server established in the data center, right? So classic example is the HTTP, IMAP, and FTP. So we will talk about HTTP, IMAP, FTP in detail later, but general speaking, so here I can give you a quick introduction of what they are, right? So for HTTP, it stands for the Hypertext Transfer Protocol. You can easily search online or in Wikipedia or somewhere just very quickly, right? So it's the application layer protocol for transmitting the hyper medium documents such as HTML, right? And it was designed for communication between web browser and web servers, just as we mentioned, right? You install web browser in your end, and the server provider or the web page provider, they will install the web server in their end, right? And you are the client, they are the server. So you will send a request to them, right? And they will respond to you. They will respond to you. So HTTP is a application layer protocol for hypermedium documents such as HTML, right? Okay, and what is IMAP? So IMAP is the Internet Message Access Protocol, okay? Also, you can easily find online. It's an internet standard protocol used by email clients to retrieve the email message from a mail server over TCP/IP connection. So generally speaking, or simply speaking, they just protocol to receive your email from your email server, right? Through the TCP/IP. So we will talk about what is TCP/IP, but generally speaking, they are a protocol for email receiving service, okay? And maybe some of you know the POP, right? POP, Post Office Protocol. That's nowadays I think most of the people are using the IMAP to receive the emails. because you don't need to download the email. It have a good synchronization features, right? But back to maybe 2000 or before 2010, people are using the POP is a type of a computer networks and internet standard protocol that extracts and retrieves the email from a remote mail server for access by the host machine. So the difference between the IMAP and the POP is that usually when you are using the POP protocol to receive the emails, every time it will download the complete email contents attachments to your local local device, right? But using the IMAP, it's not the case, right? It's, for me, at least for me, I don't want to keep all the emails in my local, right? And sometimes if I have already read this email, I want to my cell phone to be synchronized, knowing that I have already got this email or reading this email, right? But I mean, different protocol have different benefits and advantage and disadvantage. We will talk about that later. Here, just to give you a quick idea, what is the HTTP, IMAP? Oh, okay. The last is the FTP, right? I think FTP, you should be familiar. We have a FTP server established in the department, right? So people can upload the document to the server, right? And students and other faculty can also download the file from the FTP server. So FTP server is a standard internet protocol for transmitting files between computers on the internet through the TCP/IP connection. Okay, it is also a client-server protocol where a client will ask for a file and the local or remote server will provide it just for the file transfer. So from the name, you can tell that file transfer protocol, FTP, right? Okay, so we will talk about, no worry if you maybe you want to know more details about this protocol, so we will talk about that later. But HTTP, IMAP, FTP, all these three protocols are based on a client and server paradigm, okay? So you have the client, for example, email, right? You have a phone, you have a laptop, you install the client software, right? And for the server side, they installed a server program, right? Email server program. So you can use the client and server paradigm to communicate with both sides. Okay, so no question about this, right? So this is a very classic paradigm in the application layer. So you have server, you have client, right? And sometimes people may talk about in distributed computing or some area, people are talking about the master and the slave, right? It's similar, right? Master is something you provide control, right? Or slave is you are doing something. But both of this concept are similar, right? You have some central part and you have the client and you want to request or ask for something. And compared to the client and server paradigms, we also have the peer-to-peer architecture or paradigm, okay? Because sometimes server are not always running, right? And arbitrary end system want to directly communicate with each other. Just as I mentioned, you have a laptop, you have a desktop, you have a mobile, and if you are using the client and the server architecture or models, this device cannot communicate with each other, right? Because they are all clients. They can only communicate with the server part, right? But sometimes your laptop wants to talk to your desktop, wants to talk to your mobile phone, right? So you can establish a peer-to-peer architecture, right? So the arbitrary end system can directly communicate or talk to each other. And the peers request service from other peers, provide service in turn to other peers. So it has the self-scalability. So new peers bring the new service capacity as well as new service demand. So you add a new device into the network, it brings the capability, right? And you increase the scalability of the network, right? but they just communicate with each other individually or directly, right? So the peers are connected and change IP address from time to time. It is complex to manage that, okay? And the P2P file sharing is, you may know that there is some P2P file sharing or download, right? Sometimes it could be faster than client server model, because if you have a central server, many people are trying to download the file from you, and your bandwidth, you understand the bandwidth concept, right? And bandwidth may be limited, um, even if it's a server, it's a central part, right? But the bandwidth could be limited. If you are if you are using the P2P file sharing, for example, if someone has already downloaded that part of that file, and you can request part of the file from server or from the other people at the same time. That means you are not kind of limited by the server bandwidth, right? Because you are directly talking to the other people. They can directly send the file to you, right? So here are some concepts that P2P file sharing could be sometimes faster than the client server file downloading. Okay, but it's complicated to establish how, I mean, for example, you want to download 100 gigabytes of the data, and which part of the data sent by other people, and which part of the data sent by the clients or the other part, right? You need to have some schedule here. But generally speaking, the P2P architecture could bring you some benefits in terms of the bandwidth or speed, right? Okay, so these are two classic paradigms or architecture or models you need to understand in application layer. One is the client server, okay, and one is peer-to-peer. So we will talk about how to implement that using the socket programming. Okay, how to implement a client server, right? You can initiate two processes. One is a client, one is a server, right? But we will talk about that later. Here's just a quick concept introduction about the architecture. So next is the process is the communication. Okay, so the process is a program running within a host, right? It's similar to the operating system process concept, right? You can initiate or launch a program with the process, right? Running within the host. So that means the host could be running multiple or many processes and programs at the same time, right? It's not necessarily the only server only running one host only running one process or program, right? Multiple processes can be running in the host. So within the same host, two processes communicate with each other using the inter-process communication defined by operating system. So if you have some basic concept of the inter-process communication, you may understand this part. So for example, if I launch two processes in the operating system, right, there is a scheme that allows the process to communicate with each other and synchronize their status or their actions, right? The process can communicate or talk to each other through the shared memory or message passing interface. So what about shared memory? What is the message passing interface? Maybe some of you have already learned the parallel computing or something. So in parallel computing, we usually talk about the shared memory, right? So what is a shared memory? In your laptop, right, you can launch two processes. Both of the process can access to the same memory space, right? So we call it shared memory because they are sharing the same memory space. So they can use the shared memory to communicate with each other, right? For example, process A write the data to location 1, right? And process B read the data from location 1, right? Then they finish one data exchange or communication, right? And another thing is the message passing interface. They don't want to use the memory to exchange the data, okay? They can just directly send the message to each other. So message passing interface is MPI, right? So if you have some experience in MPI programming, you may know that MPI is not limited in the same host. They can be across the different hosts. But anyway, here, this is not the important point. Here, the point is that within the same host, the two processes can communicate with each other using the inter-process communication. So sometimes operating system can control that, okay? Or you can program that, okay? Um, let me check if there is any question. Okay, seems no question. Yeah, thanks Ace. Those the BT is the short for BT, like BitTorrent is a good um, peer-to-peer file sharing, right? So sometimes if a lot of peers join the network, and your download speed could be much faster than client server model, right? Thanks for adding the note. Okay, and for the client and the server, usually we initiate the program or process in the client side and in the server side as well, right? The client process will that process will initiate the communication, and the server process will wait for the wait to be contacted. So that's why a client called client, because they actively send their request, right? They initiate communication, and the server is just sitting there and waiting for the client to contact him, right? Or contact the server process. Okay. Note that the application with the P2P architecture have client process and the server process as well. Okay, they also need to have the process to communicate with each other. But I think because this is the P2P, right? Both of the peers can initiate a client process and the server process at the same time. Okay, so this is a basic concept of the process communication for the client server and the client and the server. Okay. So the next is a socket, the concept of socket. The socket is what is a socket, right? Socket is a conceptual thing, right? The process will send and receive message to or from its socket, okay? And we can think about socket like a door, okay? The sending process first pushes the message out of the door, right? Out door. So just the application will, the process running in the application host, right, will first send, push the messages out of the door or out of the socket, okay? And the sending process relies on transport infrastructure on other side of the door to deliver message to socket at the receiving process, okay? And then the receiving process just get the message from outside of the door to inside of the door, okay? And during this process, the two sockets will be involved, each one on each side. Okay, so generally speaking, we can think about the socket is a software structure. It's a software structure, okay, within the network node that serves as the endpoint for sending and receiving the data across network. You can think about it as the endpoint, right? But it's a software structure within one node or host, right? Serves as an endpoint for sending and receiving the data across the network. So the structure and properties of a socket are defined by an application programming interface or API, right, for networking architecture. Sockets are created during the lifetime of a process and of application running in the node. So that means if the process is killed, the socket will be stopped as well. Okay, but this is just a basic concept. For more details, we will talk about how we can utilize the socket. We can do the socket programming, okay? So we can create a socket, and we will use socket through the TCP IP to send and receive the data. Okay, we will have some programming example later. But socket, you can just think about it's an endpoint or like a door, right, to control the message in and out. Okay, so the next question is that let me check the question. Okay, I think there is no more question. Hold on 1 second. Let me adjust the window so that I can see the question, your question, and see the slide at the same time. Okay, that's good. Okay, the next question is that to receive the message, the process must have the identifier. Okay, so how you identify, right? Which process you want to send the packet, send the message to, right? There are a lot of process in the host, right? So then the question is that, okay, so first is the IP, right? Everyone should maybe know the IP, right? The host device has a unique 32-bit IP address, right? Each host will have the IP, right? You have your laptop have the IP, my laptop have the IP, right? But the question is that does the IP address, is the IP address sufficiently enough for identifying the process? The question is that, can we just use the IP address to identify the process we want to communicate with or talk to, right? So that's the question. So anyone know the answer of the question? Or, I mean, yes or no, but no, why? Right, yes, that's right. You probably need a port number. Yes, that's correct. So no, and what about port, right? So some of you may not know the port, but the answer is no, because many processes can be running on the same host at the same time, right? Many processes, many programs can be running at the same time. And we may also need the port, right? So what is a port? So the identifier usually includes the IP address and the port numbers associated with the process on the host. Okay, so for example, for HTTP server, we have the port number 80. So for okay, so here is the case. You can think about the IP address is the identifier to the end system or to the host, right? Inside or within the host, you still need to identify which process you want to talk to, right? So then we give a different process a number, and we call the number as a port number, okay? For example, the HTTP server usually running with the process with the port number 80, right? And for mail server, it has a port number of 25. So for example, if you to send the HTTP message to this is IP or the DNS, right? It will automatically convert to IP address, a web server, okay? And then the HTTP will identify the port number 80, right? So they can know that, okay, I'm talking to the web server running with the port number of 80, right? Or process of 80, right? So we will cover more shortly, but generally how you identify addressing a process, you need to have IP address and the port number at the same time. Yes, that's a good question. So what is the difference between the socket and the port? So a socket is externally identified to other hosts by its socket address, which consists of the transport protocol, IP address, and port number. So that's right. A socket is generally speaking, or roughly speaking, it consists of three-part transport protocol, IP addresses, and the port number. Okay, so you can think about that door, right? That socket contains three different parts, but because we are not talking about transport protocol now, so IP address and port number are the necessary information we need to know for the socket. Okay. And for the protocol, we will talk about later, right? Transport protocol. We have TCP, we have UDP. Okay, no worry about that now. So for application layer protocols, it generally defines different things, right? I mean, the question is that what you should include in the application layer protocols, right? What application layer protocol defines. It will define the type of the message exchanged, right? Request or response, right? For the client, they will send the request. For the server part, they will send the response, right? So types of the message exchanged, right? What type of the message, request or response, and it will contain some it defines the message syntax, right? What fields in the message and what fields are described in the message, right? The syntax, right? You need to describe the syntax. And the message semantics, right? The contents of the message, meaning of the information in the fields, right? And finally, it will define the rules for when and how process send and respond to the message. You need to give me some advice, right? When and how I should respond to you, right? And that's a basic thing we need to the application layer protocol needs to include, right? Basically speaking, but we will give you a detail about HTTP in a later slides. What HTTP the protocols or request or response includes, right? They will include the URL. They will include the different useful information in the protocols, okay? And for the open protocols, it's defined in RFC. I think we have talked about RFC, right? It's a standard. It's a request for comments, right? It's a standard defined by some, I think it's the IEFE organization. Okay, so everyone have access to protocol definition. It's an open protocol. Okay, everyone have the same standard because this is the standard that the industry, academia, people need to be aware of and to be consistent with the same protocol, right? So they can develop the same application because they are using the same protocol. Not same application, sorry. They can develop the different application, but using the same protocol because the protocol are open, right? But sometimes the protocol are not open, right? For example, the Skype, right? That protocol is a private protocols, right? It's not open for everyone. Only the Skype, that software, know what is the protocol inside, right? Not everyone can talk to Skype, right? Only Skype user can know how they communicate with each other. Okay. Yes. Right. Yeah. So, but I think mostly we are using the open protocol, especially for academia, for learning, right? These protocols are commonly used are open source, right, and open protocol, not privately owned by some company. Okay. And what transport service does the application need? So as I mentioned before, for a socket, it consists of a transport service, a transport layer protocol, right? And IP address and the port number. So what the transport service, generally speaking, does application need, right? Because some application will be very time sensitive. Some application is fine. I just send something, no matter when you respond to me, I'm fine. It's not very sensitive, right? So what the service does the application need? So first is the data integrity, right? Some application requires 100% of the or complete reliable data transfer. I cannot lose anything, right? I have to make sure every message, every package will be successfully delivered, right? So I think last week we played a video, right? Talk about the TCP/IP, right? The idea I think is straightforward. You send a lot of packets, right? And the receiver just replies it can receive the packet in different order, but it will reply to you which packet I have already received that, right? It's called acknowledgement, right? And if the receiver didn't acknowledge some package has been received, the sender will resend the packet, right? So that's some idea about the TCP/IP. They can guarantee the complete or reliable data transfer, right? They don't want to lose any data, okay? But some other applications can tolerate some loss. That's very important. I think for my personal research interest, my group is doing some lossy compression, some data reduction. For that application, we are usually taking care of can tolerate some data loss, right? Because sometimes we don't need to have a 100% of the data to be sent, like audio, like a video, like an image, right? As a, for example, JPEG, that's an image, right? Sometimes you open an image, that image has different resolution, right? You have high resolution, low resolution. High resolution will have a very have more information, right? It can give you better idea of what does a picture include some information, right? But sometimes you don't need to have that or such accurate a picture. Then you can lose some resolution, right? You can lose some pixel, you can lose some colors, whatever, right? As long as you can recognize that, what does that picture mean, right? That's okay. So for some application, we definitely can tolerate or lose some information. So for that application, maybe, right, we don't need to use the TCP protocols, because TCP protocols need to guarantee reliable data send and receive. That means you need to pay some overhead, right? You need to send acknowledgement, right? To make sure people or the sender the data has been already received, right? To make sure the sender will not resend that, right? But for the application can tolerate loss, they can use, for example, UDP, right? The UDP will be very fast. We will talk about that later, but that will be very fast. You don't need to make sure every packet will be received. Then you can understand that, right? And then the speed will be better. Okay, so it's generally speaking, what kind of the transport service does the application need will decide what kind of the transport protocol you want to use. Okay, so we will give a table later. Also for timing, similar for timing, some application, right, require low delay. Because if you talk to someone, you don't want to, I say this sentence and then you get that sentence in 10 seconds or 20 seconds, right? The delay, if the delay is very high, then our communication is very conversation would be very bad, right? Some application is very time sensitive. That's the point. And also some application needs to have a high throughput. Okay, for example, the multimedia, video, audio, right? You need to do a streaming video, then the throughput needs to be very high. But for the web service, web server or HTML or browsing a website, you don't need to have a high throughput, right? Because you just click and all the data is loaded and then you can browse the website, right? Here is a good connection here. For the data integrity and the throughput, sometimes they are in a trade-off. Okay, if you want to guarantee 100% of the data to be delivered, then maybe you cannot guarantee a high throughput, right? So that's why that no one rejects to or refuse to receive a very high resolution of picture or video, right? But sometimes if you want to do that, you need to wait for a long time or the throughput would be very low. Okay, so here is some trade-off. That's why when you are looking at the YouTube streaming, you want to choose a different resolution, right? 360p or 1080p, right? So they have the different resolution here. So it's related to the throughput, but also related to the data integrity, okay? And the last thing is the security. Some data you have to be encrypted, right? You want to the data cannot be stolen by the other people, right? Even if they just get the data, they cannot read or understand the message or the data, right? Because you have the data has been encrypted, okay? So here's some general idea what kind of the service and application needs. So here's a summary table. We can quickly look at that. So for file transfer, the download file, you cannot tolerate loss, right? If I download the homework will be lost, right? You only get the half of the assignments. That's ridiculous, right? So no loss could be tolerated for the file transfer or download, right? But if this is a time sensitive, it's not quite time sensitive, right? As long as you finally get the file, that's fine. Okay, for the email, the same thing, right? You cannot tolerate loss. The throughput is okay, it's flexible, right? But and the time is not quite sensitive, similar to web document. But what is the difference? The real-time audio or video. Just as I mentioned, they can tolerate the loss, right? They are very time sensitive because you don't want to wait for more than some milliseconds, right, to talk to the other people, okay? And they have some requirement for the throughput. Just I mentioned, if the resolution of the video or audio is very high, and then you have to guarantee the throughput, okay? A streaming audio video, same thing, similar, right? And but the streaming audio video could be less time sensitive because it's not a real time, right? Real time, I talk to you and you respond. If I ask a question and I wait 10 minutes, then you respond, it's not good. But when I watch the YouTube video, even if a 10-second delayed, maybe you don't know, right? Because you start from the beginning to the end and the delay could be overlapped or pipeline. So you cannot sense that you have some delay sometimes, right? And for the interactive games, it can tolerate some loss, and it has a lower throughput requirement, and it has some similar time sensitivity as a real-time audio video, okay? So here is a TCP and the UDP protocol service, because we just mentioned that we want to have the reliable transport, right? Or send and receive. So the TCP could provide that to you. But for UDP, right, it's an unreliable data transfer, just as the word tell you, right? It's an unreliable data transfer protocol, right? It can provide a high throughput, high speed, right? But it cannot guarantee your reliability. I think I will go through that slides in the next lecture, but in the end, I want to quickly show you these slides. So this slide will give you some idea, because previously we define what kind of application needs what kind of the transport service, right? So if you understand every detail for the TCP and the UDP, and then you can do a corresponding a protocol to the application, right? For example, here's a quick example for the streaming audios, videos, right? And because you don't need to have a 100% data reliability, right? And then you could use the UDP, right? And for the internet telephony, right? You just talk to someone through the internet, and then, for example, Skype, and then you may also can use the UDP, right? But also TCP is okay, but sometimes if you want to optimize the performance, UDP is the choice. Okay, so next lecture we will continue to talk about the detail about TCP, UDP, and the application using the different protocols. And then later we will talk about the web and the HTTP, email, DNS, P2P one by one. Okay, so for this lecture, I just give you a quick overview of the principle of the application layer protocols and some principle and some concepts. Okay, so any question for this lecture or for the assignment class? Any question you can talk to me here. So I may give you some 2 or 3 minutes. If you don't have question, just feel free to leave. But if you have question, I will stay here for maybe 2 more minutes. Yeah.
I'm kind of stuck on the homework a little bit, just in terms of terminology. Do you think the book chapters you've published would help?
You mean that some concepts in the assignments were not covered in the slides, right?
Yeah, I don't think so.
Okay, yeah. So I think, yes, I know that some, for example, the bit width, some concepts are not covered in the slides. But I think that concepts are not difficult. I want you to self-learn or search the concept, and I think it's not difficult concept, but if you feel difficulty to understand that concept, just feel free to let me know, and I can provide you some more materials to that. But generally speaking, that concept, I go through that question and answers, and I think that concept can be easily found online or the
Okay,
textbook.
so the internet's our friend for this one, ironically enough.
Yeah, yes, that's my point. Yes.
I also have a question about the homework. On problem number 7, you ask for the total delay with the network with 2 routers in it, but it doesn't look like you give a processing delay for each router. So I'm not really sure how to calculate that. I just assume that the processing delay would be small.
Yes, for that question, if I didn't give you the processing delay, so you just for still remember that formula, we have the different parts, right? We have the 4 components: processing delay, some delay, some delay. So if I didn't give that in the question, that means I assume we can ignore that time, or the time would be very tiny. So you don't need to count that time, and you need to consider the major part, for example, the propagation time and the queuing delay, something here, okay?
Okay, and then for the queuing delay, I assumed because seemed like it would be much less than 1, that the queuing delay was 0 in this case. Is that kind of what you were hoping for?
Yes, that's right. So for the question 7, because some of the students may already leave, and I will send a clarification for that. Thanks for bringing that to the class. Yes, I will send the clarification, and in the future or in the test, if I didn't mention that delay, that means that delay we can safely ignore that. And just as I mentioned, processing delay sometimes is very small, right? And we usually consider the later 2 parts.
Thank you.
Thank you. Okay, so if there is no more questions, that's it for today, and thanks for attending. So see you on Friday. Okay, thank you, everyone.
Thank you.